Our last section look at execution parallelization. So how Spark works. In Spark, user applications will create RDDs or data frames, and then they will transform these data frames or RDDs and run some actions on these data frames or RDDs to obtain some results. And this will basically result in a DAG, which is a directed acyclic graph. Right? So it will be a graph of those operators, of those transformers and actions. Right? So that will result in a graph. And then Spark will compile this graph into stages. Right? So to compile this graph into stages. And then each stage is executed as a series of tasks. Let us look at an example of word count in Spark. Suppose we want to count the different words in a text file. And so this is a text file. So notice here, we use SC, the Spark context. So what we are doing is to create an RDD rather than data frame. So this is the word count problem. Suppose our text file is very simple, has only 6 words, to be or not to be. Right? So how to do the word count on this text file? Right? So the procedure is first we separate this into individual words, right? So these two, be, or, and so on, right? So then we map these words into a key value pair, right? So key value pair. So each word will become a key to be, or it will become a key, and we initialize the count as 1, right? So there's one such word, 1 and 1, right? So like similarly over here, right? So then we will compare the key, right? So then we will compare the key and sum up, right? So sum up those pairs with the same key. For example, B, right? So B here, there's a one key with B over here with 1, and there's another, right? So therefore we add it up, right? 1 plus 1 equal to 2, right? So, and for these 2, right? So there's 1, 2 over here, another 2 over here, therefore it is 2, right? So therefore 2, we have 2 2s, right? So, and for all, there's only 1, and not, there's only 1, right? So therefore, this is the final output of the word count, right? So the word count is saying that there are 2 B's and 2 2's and 1 not and 1 all, right? So that is a word count problem, right? So therefore, in Spark, the first thing we do is flat map, right? The flat map here is more like those as a tokenizer we have seen earlier, right? So it basically splits the text file by tabs, right? By tabs, and what we obtain are words, right? So it's a list of words. And next, we do a mapping. We map each of these words into a pair of key, which is a word, and a number 1, right? So an integer 1. So the result is a list of data sets of pairs of string plus integer, right? So it's a word and it's count. Next step, we do a reduce by key, right? Reduce by key and sum up, right? So it's saying that reduce by key, sum up, right? So that is to say that we sum up those with the same string, right? Same string, we add it up. Right? So that is basically reduce by key, right? So therefore, at this stage, you need to look at, right? You need to look at the other partitions, right? You cannot do it on just on one partition. You need to look at other partition to see whether they have the same key, right? They have the same key. But in comparison, right? So the previous flat map, right? The flat map and map can be done without looking at other partitions, right? Without looking at other partitions. And finally, right, so we have an action called collect, right? So called collect is to collect these key and value pairs and resulting an array of string and integers, and finally return to the driver program, right? So that is the flow, right? So in Spark, there will be an execution plan, right, formulated, right? So the scheduler will examine the RDD's lineage graph to build a cyclic graph of stages, right? So to build a graph, right? Build a graph like this of stages. Right? Here, there's 2 stages, right? Here, there's 2 stages. How to decide how many stages, right? So basically, stages are sequences of RDDs that don't have a shuffle in between. That means within a stage, there should be no shuffle of data. That means the partitions will not need to look at other partitions. They do not need to look at other partitions. But here, don't need to look at other partitions, right? So there will be no shuffling of data. They just pass on the data. And so that is how to decide where there should be a stage, right? So for example, here, it just pass on the data. There's no crossover, right? So therefore, this kind of crossover, right? So it means there's shuffling of data and shuffling of data. So this is a boundary, right? So this, if you see shuffling of data, that should be another stage, right? That should be another stage. When you run the programs, right? So in this PySpark shell, right? So you can see the stages, right? It displays stage 1, 2, 3, 4, and then finish. You just erase it, right? So erase it. So those are talking about the stages over here. And therefore, for this particular example, there will be two stages, right? So, and this is the boundary is where the shuffling is happening. And in stage 1, what we do is that we will read the text file and then split it. I split it into words and apply both of the maps, right? Apply the flat map and this map, a map to the key and value, and then start partial reduce within the same partition, right? So it basically start the reduce by key within the same partition, right? So to do the reduce by key within the same partition, then it will write the shuffle data, right? Write actually the aggregated results, right? So the reduced results, write the shuffle data. That will be the end of stage 1. Then when we move on to stage 2, the stage 2 will read the shuffle data, right? Written by the previous stage, and then do a final reduce, right? Final reduce to aggregate the result from different partitions, and then send the results to the driver program, right? So that's what stage 2 is doing. Then let us look at how the tasks are executed, right? So Spark will basically create a task for each partition in the new RDD, right? So if there are 4 partitions, there will be 4 tasks. Then Spark will compute the task's closure, right? So another terminology. It will compute the closure. What is the closure? Closure is means those variables and methods that must be visible to the worker will be packaged, right? It will be packaged as a closure, right? So the closure means a package of those variables and methods that must be visible to the worker, right? Must be sent to the worker, right? So then Spark will serialize, right? Serialize the tasks closure, and then schedule and ship, right? Ship the tasks, which means the closures to the workers, right? To the workers. And since there are multiple partitions, so actually the user can set the level of parallelism, right? So basically, there are many transformations, right? There are many transformations. We'll take an optional parameter called number of partitions for you to specify the number of tasks. Right? So here are some of the transformations, right? Where you can specify an optional parameter called number of partitions, right? So it's optional. And lastly, we want to have a brief discussion of shared variables, right? So which will be more useful when you work on a cluster, right? So in our lab, and in this module, we will just work on local cores, right? So therefore, you don't have to worry about the shared variable much, right? So, but if you go out to work, actually work on cluster, right? So this is very important that you need to know, right? So we know that the variables are distributed to workers, right? So via closures, right? Via closures. Therefore, when a function is executed on a cluster node, it works on separate copies of those variables, right? So that are not shared across workers, right? So these variables, once shipped to the cluster node, they will not be shared across workers. So this will bring some issue. For example, if there are some iterative tasks or some single jobs with very large global variables, right? So then in this case, it will be very inefficient to, if it's iterative, right? If it's iterative, it will be very inefficient if we send the large data for each iteration, right? Because you know the data is fixed and you don't have to send it each time, right? So each iteration. So the solution is to use broadcast variables, right? Broadcast variable. For these variables, they will only be shipped once, right? And then they will be kept over there rather than shipping for each iteration. And we will briefly study it in the lab, right? So another case is for counting events, right? So counting events that occur during the job execution, right? For if there's some counting happening during the job execution, because the variables are not shared, right? So therefore, you can't share across the job, right? So therefore, the problem is that closures are just one way, right? You just move from the driver to the worker, right? So there's no way that the worker can update the variable in the driver, right? So this will need a new data type called, or method called accumulators, right? Unique accumulators. This will be something that you can only add it to, right? So it will be accumulator that you can only add it to, such as sum or counters, right? So the accumulators will be also a shared variable across workers, right? To be shared variable across workers, right? We will have a brief look at accumulators in the lab, right? So, but we don't go into details. There are some recommended readings, right? So that's the end of the technical content. And there are some quite good recommended readings. This is a tale of three Apache Spark APIs, RDD, data frame, and data set, right? You can read about the history of the evolution from RDD data set to data free, right? So section 2.4.2 and 2.4.3 of the book, massive data mining massive data set, now is in its third edition. It is also very good, and I recommend you to read it. Also, please refer to the hyperlinks in the slides, which provide additional readings and also suggested reading in lab 2, right? So and that's the end of this lecture, right? So in the next part, I will give an overview of the lab, okay?